Okay, so welcome back to another video. So in today's video we actually have an integral, but this is actually a little interesting looking. So we have a bunch of nested exponents. So we have that the integral of from 0 to 2021 of our integrand of 2021 to the power 2020 to the power 2019, so on and so forth. You get it, it's like nested exponents. Stops at 2 to the power x, and then the product keeps going so on so forth all the way up to 4 to the power 3 to the power 2 to the x, multiplied by 3 to the power 2 to the power x, and then multiplied by 2 to the power x dx. So you can kind of see the pattern of like as each numbers pass by, it's just, you know, as each base constant decrease by 1, so does the exponents of the nested exponents decrease by 1 as well, as you can see. So I know it's a little scary looking trying to integrate just from the looks of it, but it's not as complex as you think it is. Of course, obviously, we can already just tell that if we integrate this, we're going to get some big numbers, but we're not going to evaluate it as a full, but just but there are a couple techniques that we're going to be doing here that it's actually going to come out nice. So to do that, let's actually start by using a u-substitution. We're going to let u equals 2 to the power x. Okay, so differentiate both sides. So du is equal to 2 to the power x multiplied by ln of 2 dx. Okay, and so what I'll do is that just to get the 2 to the power x dx by itself, I'll just divide an ln of 2. So I get that du is equal to the natural log of 2, and then that's equal to the equal to 2 to the power x dx. Okay, good. So I'll just do that substitution, and so we get that this is 1 over ln of 2, and simply I just factor out the 1 over ln of 2 outside since that's just a constant. Multiply by our integral. So let's see, new bounds. So let's see, if I plug x equals 0, we get that the lower bound is 0 or 1. The lower bound is supposed to be 1. And then our upper bound is, so it's just 2 to the power 2021. We're not going to evaluate that in full, just write it like this. Okay, and then we'll just write everything out as it is. So let's see, well, not necessarily. So 2021 to the power 2020 to the power 2019. Okay, keep going. And then this time replace the 2 to the power x instead, that will be u. So this time we'll have 3 to the power u, and then multiply, the product keeps going forward. So we get that this is 4 times 3 to the power u, and then next we have it's multiplied by 3 to the power u, then du. Now let's actually do a second u substitution. This time I'll actually define this letter as v. So v is equal to 3 to the u to the power u. Okay, so I do the same thing. So dv is equal to 3 to the power u multiplied by ln of 3 du. And then we're just going to do the same method just like before. I'll just divide the ln of 3 both sides just so we can do the substitution for 3 to the power u du. So I get that dv divided by ln of 3 is equal to 3 to the u du. Okay, then we do the same thing just like before. So just factor out the constant of the denominator of ln of 3. So it's ln of 3 multiplied by ln of 2 from that denominator, and we have 1 as our as part of our numerator. And then we have to evaluate our new bounds. So let's see, if I plug 1 for u, so that means this is going to be 3. And if I plug 2 to the power 2021, then it will be 3 to the power 2 to the power 2021. Okay, then we do the same thing. So 2021, 2020, 2019, let's see, so far, so forth. And then replace the 3 to the power u with just v. So this time this will be 4 to the power v, and then multiply this through. We get that this is 4 and then to the power v dv. Okay, now let's actually do another substitution another time. I'll call this one m. So m is equal to 4 to the power v, then dm, get it, is equal to 4 to the power v multiplied by ln of 4 dv. Just do the same thing again, just divide the ln of 4 to both sides. I'll get that dm is dm divided by ln of 4 is equal to 4 to the power v dv. Okay, and then I substitute, and then I'll factor out the natural log of 4 outside into the denominator. So we'll see ln of 4, ln of 3, and then ln of 2, and numerator is 1. Then we have our new bounds. So let's see, I plug 3 for v. So let's see, this will be 4 to the power 3. And then, let's see, 3 to the power 2 to the power 2021, that goes here. So that means this will be 4 to the power 3 to the power 2 to the power 2021. Okay, and then do the same thing. So we have, this is 2021, 2020, 2019. And then this time 4 to v is m, so this time that we will have 5 to the power m. Then multiply this product through to get 5 to the power m dm. We could sit here all day and just do this manually for like many times until we just get an easy term to evaluate. But that's gonna take forever. So let's actually do a little observation on this when we do this method. So continuing this method, you can obviously see that there's actually a pattern going on with what we're doing, especially with this method. So notice that every time if we substitute the lowest exponent, so coming from over here and then over here and over here, that lowest exponent, we'll just call that a, for example, the constant a, and then that was raised to the power x or whatever variable we are using in each of these steps, let's say. We notice that this integral actually reduces, and this actually this is gonna leave us with each factor of 1 to the power 1 divided by ln of a. When we do this amount of times, we actually see that our bounds, we get some nested exponents. So this means that continuously doing this many times for some constant a, we get that, I'll write it like this. So each factor comes out of so 1 divided by ln of a. And then also our upper bound, specifically, we can write this as a to the power a minus 1 to the power a minus 2. And that keeps going so on and so forth all the way up to 2 to the power 2021. And then the lower bound, if we continuously do this many times, we get that this is just a to the power a minus 1 to the power a minus 2, so on and so forth, all the way up to 4 to the power 3. Writing this forever and ever, this is going to take a while, so well, eventually later I'll just write some letters to denote some things. Okay, so each time we factor out the ln of a, you can see that we're getting like some sort of product series below. So after doing this 2019 times, if you want to manually do this yourself, you can, but it's gonna take forever, so I wouldn't bother with that. You just notice the pattern, and you can actually take the shortcut and a little detour to see that you can actually rewrite things a little bit easier in this case. So therefore, if we were to do this, like I said, the substitution 2019 times, then we would actually get the following. So I'll write this in purple just for denoting something new here. So this means that we would actually get the product series starting from our index k is equal to 2, because that's what the ln of 2 comes from, that's from the starting index from there, and we increment each by plus 1. We continuously do this for 2019 times. We get that now the upper index is supposed to go up to 2020 of 1 divided by ln of k. Okay, and then we actually get our integral. So we plug this upper bound, so that means that this will have a will have to be 2020. So we get that, we get that our bound is our lower bound is 2020, 2019, okay, and then all the way up to 4 to the power 3, and then over here we get that this is 2020 to the power 2019, and then hold on, let me write that a little better. 2019 all the way up to 2 to the power 2 to the power 2 to the power 2021, and we get that this is just 2021 to the power u du. Well, I know I already said u already, but we're just sticking a different variable in this case. Okay, so that's actually not that hard to show. You know that, so I'll put this. We know that the integral of some constant a to the power x dx is simply just equal to a to the power x divided by ln of a, and you know, plus c, just because this is an indefinite integral, but we have our bounds, so you don't need to worry about that. But doing this, we get that this is, so I rewrite the product series again, 2020, k is equal to 2 of 1 divided by ln of k, and then we have, let's see, let me just denote, because the exponents just get bigger and bigger. Let me just call this, I'll call this, I don't know, maybe f, and I'll call this lower bound g. Okay, it's just a lot to write from there. So, okay, so this means we get our new integral, our evaluated integral. So 2021, what is it, u, and then divided by ln of 2021, and then evaluated from, I just defined this as f and then g. Okay, what I can do is I can actually factor out an ln of 2021. Well, what that does is, however, that actually changes our index of the product series. So this time we get that this is now going to go up to 2021, and then starting with k is equal to 2 of 1 ln of k, and then this means we get that this is evaluated from 2021 to the power f, and then minus 2021 to the power g, where I'll just write this again, where f equals 2020, 2019, and all the way up to 2 to the power 2021, and then g is equal to 2020, 2019, all the way up to, or that's supposed to be 4 to the power 3. Okay, and there we have it. That's the final conclusion of this. I dropped my eraser. That's the final answer to this integral over here, all in this box, like so. Okay, that's pretty cool if you ask me.